Welcome to the day 5 notes. I'm going to have you pause the video, work through these warm-up questions, then unpause the video to see how you did. Okay, so for this first one, there are a lot of possible vertical angles. So I'm going to have vertical angles. There's going to be a list. Adjacent angles, there will be a list, and linear pair, there will be a list. So for vertical angles, you could have angle 3 and angle 5, and that is the only possible vertical angles that you could have. For adjacent angles, there is a whole lot of them. Angle 1 and angle 2, angle 2 and angle 3, angle 3 and angle 4, angle 4 and angle 5, angle 5 and angle 1. You could have had any of those. You didn't need all of them. You just had to find a pair of adjacent angles, but those are all of the possible pairs. And then linear pairs, you could have had angle 3 and angle 4, or you could have had angle 4 and angle 5. Those are the only possible pairs for the linear pair. For the second one, what's the angle measurement for angle 2? It tells you given, but you do not have to write a full proof. But you should be able to figure out that if 1 and 3 are the same, that 2 and 85 degrees are the same. So I know that angle 2 is 85 degrees. So that tells me that measurement of angle 2 equals 85 degrees. You can figure this out because angle 1 and angle 2 are a linear pair. Angle 3 and the 85 degrees make a linear pair. You could substitute the measurements of angle 1 and angle 3 together to figure out that angle 2 is going to be 85 degrees. Okay, measurement of angle 1 plus measurement of angle 2 equals 180. Measurement of angle 3 plus 85 equals 180, right? Since they're both equal to 180, you can set them equal to each other. Measurement of angle 1 and angle 3 are the same, so you'd be able to subtract that out. That's how you get measurement of angle 2 is 85 degrees. So today there's going to be a lot more of definitions and things to write down. So parallel lines, I think everybody knows that parallel lines never intersect, but in geometry we need to be a little bit more specific. These are coplanar lines that never intersect. Okay, anytime you've talked about lines in the past when you were younger, you always talked about coplanar lines without realizing you were using coplanar. But the reason why that's important is because skew lines are non-coplanar lines that do not intersect. So the fact that we have coplanar is important. So I'm going to go back to the parallel lines real quick. The way that we denote that lines are parallel is we put another arrow going that same direction. I'll just make that a little more pointy. Okay, and if we had another set of parallel lines in the same picture, for example, we would just put 2 of them on. Just like we do with congruent, we just keep adding arrows if we have more sets of parallel lines. So for skew lines, what that looks like is if you have a plane and there is a line on that plane, your skew line is going to go through that plane, not touching that line. So think if I had drawn a line on a piece of paper and then stabbed my pencil all the way through the paper without touching the line, that would be skew lines. If you stabbed through the paper right on that line, there would be a plane that contains both lines. Then they would not be skew lines. They would just be coplanar lines that do intersect. So parallel planes, you can't have coplanar planes. That would just be the same plane. These are planes that never intersect. All right. So the parallel postulate and the perpendicular postulate are almost word for word the exact same thing. Okay, so if you don't want to write out the full thing for both of them, that's fine. I kind of understand that. So the parallel postulate says, given a line M and a point K not on line M, not on line M, there exists exactly one line parallel, or one line through K parallel to line M. So if we draw a quick picture, that might be a little bit easier to see what's going on. There's line M, right? Point K is right there. There's only one possible way I can go through K and still have that same slope as line M. Okay, there's an infinite number of ways I could draw a line through K, but those would all not be parallel to M except for that one. Okay, and I said they're almost identical for the perpendicular postulate. I'm going to use different variable letters here. So given a line L and a point P not on line L, there exists exactly one line through P perpendicular, I'll say perpendicular with our symbol for perpendicular, to line L. Okay, again, I'm going to draw a quick picture. There's line L, point P. If I want to be perpendicular, same reasoning as the parallel one. There's an infinite number of lines that go through P, but only one is going to have the exact opposite reciprocal slope as line L. All right, and then a transversal. Okay, this is a line. It could also be a segment or a ray, but we pretty much only ever really use lines that intersects two or more lines, and again, it could be segments or rays as well. So there's almost as many like or this things as words in that definition, so I can see where that'd be a little confusing. But generally, we just think of if I have two lines, that line going through here. So in this case, this line, that is my transversal. Right there. Okay. So there are a whole bunch of different angles formed by transversals. So for all of these, I'm going to say that we are going to pick from a different group of four. And you'll see kind of what that means here in just a second. So I've got two lines being crossed by a transversal T right there. This is my transversal. So the two different groups of four are 1, 2, 3, 4 is a group of four, 5, 6, 7, 8 is a group of four. So these groups of four are the angles formed by a transversal and one of the lines. All right, so corresponding angles are in the same location, but different group of four. So what I mean by that is if I just think of this 1, 2, 3, 4 as top left, top right, bottom left, bottom right, 5, 6, 7, 8 would still have top left, top right, bottom left, bottom right. So my examples here are angle 1 and angle 5 are going to be corresponding angles. Angle 2 and angle 6, angle 3 and angle 7, angle 4 and angle 8. Those are all corresponding angles. All right, for this next one, alternate interior angles. Okay, alternates in the same for both alternate interior and alternate exterior. Okay, that tells me it's the opposite side of the transversal. And then interior tells me it's inside, right? Interior means inside or between. There are two E's there before the end. Inside or between the lines. So my alternate interior angles are angle 4 and angle 5, or angle 3 and angle 6. Okay, they are between the lines. When I'm saying between the lines, I mean between those lines right there. Okay, not the transversal, but the other two. All right, so alternate exterior angles, opposite side of the transversal again, but this time exterior tells me outside the lines. Right, the word exterior means outside, the word interior means inside. So for these, my examples would be angle 1 and angle 8, angle 2 and angle 7. Right? They are outside of the line, so all the way above or all the way below. They're not between, and then they have to cross that transversal. So then the last one on this page is the consecutive interior angles. Again, interior tells us inside, so between the lines. And the word consecutive is what is going to maybe throw some of us off. You could say this is as same side of the transversal. So my examples here would be angle 3 and angle 5, or angle 4 and angle 6. So I've got a whole bunch of different angle pairs. Okay, you need to make sure that you know each one of these. If you do not, there are theorems that we're going to be using, postulates that we're going to be using, that you're not going to be able to do if you do not know these things. You need to be able to identify corresponding angles, alternate interior angles, alternate exterior angles, and consecutive or same side interior angles. Sometimes I'll say consecutive interior, sometimes I'll say same side. They mean the exact same thing. All right, so we've got a kind of a messy picture here. It says name a pair of parallel lines. That's a hard thing to say when you got a little bit of a stutter going on. I've got these red arrows here that tells me that those lines are parallel, so I could say line AC is parallel to line DE. Okay, I could have named line AC differently, but it's still that same line. So those two lines are parallel. Name a pair of perpendicular lines. Okay, I know that there's a right angle here. I've got to be very careful. If you zoom in, you can tell there's just a little space between those, and that right angle stops on line HI. So I need to say that I've got line BH is perpendicular to line HI. Again, I could name those differently based off of the letters, but those are the lines that are necessary. And then name a transversal. There are multiple that you could use. Okay? The easiest one, in my opinion, is probably line BH, because line BH crosses those two parallel lines. But these lines go on forever in each direction, so I'm going to kind of exaggerate this and curve them a little bit just so you can see where they're going to go. Those two lines are going to be crossed here and there. So pretty much every single line in this picture is going to be a transversal. Line BH is the easiest. That crosses 4 other lines. Line AC will eventually cross 2 lines. Okay. Line DE will eventually cross 2 lines. They're both eventually going to cross 3 lines, actually. Line HI will cross 3 lines. Any line you picked in this picture will be a transversal, even if you don't see it in the picture, because remember, lines go on forever in both directions. Okay, now it says, is line BH perpendicular to line GI? BH, GI. I'm going to say yes. Why? Because of that right angle. This is the same thing we had right there. Okay, GI and HI are the same line. So why are they perpendicular? Because of the right angle. I'm going to space that out a little bit better. There we go. Almost. Now there we go. All right, now so we want to determine if the following statements are always, sometimes, or never true. So if two lines are parallel, then they are always coplanar. If it said if two lines never intersect, then it would be sometimes coplanar because of skew lines. If two lines are not coplanar, then they never intersect. If they were coplanar, they sometimes would intersect, if they're parallel or not. But if they're not coplanar, that means they can't touch each other. If you had two lines that intersect, there is a plane that connects both of those. If three lines intersect at one point, then they are sometimes coplanar. Okay, an example of when they are coplanar is really easy. Just like that. They all intersect, and they're all on this picture. When they don't when they're not coplanar, if I have two lines going this way, that's fine. And then if I stab my pencil right through that dot, okay, there would be a plane that connects the two that I've drawn, a plane that connects one with the arrow or the pen, whatever you want to think of going through, and a different plane that would be connecting the other one. There'd be three planes that would be necessary for those three lines. So that would be sometimes they're all coplanar. And the last one, if two lines are skewed to a third line, then they are skewed to each other. That is never true. Okay, because if I draw a picture here real quick, and I've got a line right there. In order to be skewed to that, I would have to go through this line, or through this plane, I should say, like this. In order to do that again, I would have to have another thing going through this way. Those two lines are going to end up being parallel. All right? They're either going to be parallel or they're going to be intersecting. There is going to be a plane that connects those two. Most of the time we'll think parallel, but they could be coming in at an angle as well. All right, now this last one is probably the trickiest thing to go through. It's just naming some angles, but it's confusing. I'm going to be entirely honest. It's confusing because there are three lines, and all three lines are transversals. So I'm going to go through each of these questions 3 times. Once viewing a specific line as a transversal, second time a different line, and so on. So I'm going to start off with, I'm going to highlight this and this. So that tells me that the line that I have not colored in red is my transversal. Okay, so an angle that's corresponding to IHE. So if I'm thinking of, that red line's bothering me, sorry. If I'm thinking of line GE as my transversal, okay, I have this as interior, right? And then I need to be above the other red line and to the right of the transversal, which is going to be angle EDF. All right. Now, if I'm looking angles that are exterior angles with BHG, okay, BHG, that's below the red line and on this side, so to the left and above the transversal. So alternate would need to be to the right and below the transversal, and it's got to be on the opposite side of, opposite side of the transversal. So that's also going to be angle EDF. And then name all angles that are consecutive interior angles, or we could think of this as same side interior angles with angle IHE. IHE is inside and then below, so I would need inside and below. So since I'm above the one red line, I'd be below the other. That's going to be angle HDF. And then you can name these angles differently. I could name that as angle FDH. That's the exact same thing. And then name all angles that are alternate interior with angle BHD. So BHD is right there. So that is above the one red line, so it's got to be below the other. And then it's above and to the left, so I need below and to the right. So that's going to be angle HDF again. That was if I did everything in just red. So I'm going to do another one in blue. So in blue, this time I'm going to say I'm looking at that angle. I'm going to actually erase these so we can see a little bit better. I'm going to look at that line and that line right there and say that line CI is my transversal. So now do the exact same process. This time, IHE is below and to the right of the transversal. So below and to the right, or below the blue line and to the right of the transversal is what I should have said. So below the blue line and to the right of the transversal, it's going to be angle HBD. Okay, there's a lot of ways you can name that angle, but those are the letters that I chose. Now, if I'm looking at the next one, angle BHG. So BHG is right there. Name the alternate exterior angles. If I'm looking at this, this angle is between the blue line. So there's an interior. So there's going to be no blue angles. How I'm going to write this. This is an interior angle. All right. Now, if I go on to the next angle, IHE, that's below that bottom blue line. So that is going to be an exterior angle. So again, since I'm looking for interior angles, there'll be no blue angle for this one. And then the last one, look for angle BHD. BHD, right there. Alternate interior angles. This is an interior angle. It's to the right of the transversal. So on the interior, I have one of those two angles. I've got to go to the left. So that would be angle ABH. All right. And now I've got to do the same thing again with the other one that I have not done yet so far. Looking at those two, where line AF is my transversal. Okay. If I'm looking at AHE corresponding to angle AHE, AHE is not formed by the transversal at all, so no green angle. Because you remember, these angles have to be formed by the transversal and one of the lines. All right, and the next one, BHG. BHG, same problem. So no green angle. IHE, same problem again. No green angle. And lastly, BHD is again no green angle. I have to go through and check all of those, but none of those angles that were mentioned were formed by the transversal and one of the lines. They were all formed by those two intersecting lines and had nothing to do with that transversal. All right. So here's a spot for you to write down what we talked about in this lesson and what things you're not 100% clear on. I guarantee you that you should have some questions. Make sure you're asking them, sending me an email with them, or asking them during one of our class times. All right, and then your homework is in OneNote. It's one of the worksheets it would have been if we were in person. But I hope everybody has a fantastic day.